In this session, we will be learning about DC motor. In the previous video, you saw about AC generator, right? Now we will see about DC motor, like how you made points for AC generator. Even in DC motor, you will make the points. And this question can be asked for 3 or 4 marks. And SSLC students, you should remember that in your preparatory papers, 3 times this DC motor was asked. So you need to know this. We are expecting this question even in the board exam. So first, how will you represent the answer? If they ask you to explain the working of DC motor, first you need to draw the diagram. So in the diagram, the changes that you will make is, you are using a split ring here. Got it? Here what are you using? You are using split rings, that is P and Q, what I have labeled here. And X and Y are the brushes, and they are connected to a battery, a plug key and 2 magnets. Yeah, they are placed between the pole of the magnets. All these things we will explain when we go to the working. Now, after the diagram, the next point what you will write is the definition of electric motor. So, what is the definition of electric motor? Electric motor is a device that converts electrical energy to mechanical energy. This would be the definition for electric motor. Okay, and next you have the principle. On what principle does electric motor works? So, electric motor works on the principle, when a current carrying conductor is placed in a magnetic field, it experiences a force. And I have seen people writing it works on the principle Fleming's left hand rule. No, it doesn't work on the principle. Yes, it obeys Fleming's left hand rule, but that's not the actual principle. The first principle, the first point under principle what you will write is, when a current carrying conductor is placed in a magnetic field, it experiences a force. Now see, I'll show you. Imagine that this is a current carrying conductor. If this is a normal wire, if this has to carry the current, what is that you need to do? You have to supply current. You will fix it to a battery, so that when the current is passing through, this will become a current carrying conductor. Now take this current carrying conductor, please place it in between the magnetic poles. Place between 2 magnets. You will see that this conductor will start rotating. It will experience a force. That's what your principle says. When a current carrying conductor is placed in a magnetic field, it experiences force. Got it? And in which direction it rotates? For that you need to see Fleming's left hand rule. It obeys Fleming's left hand rule would be your second point. Okay, and you will also write what does Fleming's left hand rule state. You know what is Fleming's left hand rule. When you stretch 3 fingers of your left hand mutually perpendicular to each other, then see how the points I have made here. So first you have stretched 3 fingers of your left hand mutually perpendicular to each other, and then I have made 3 different points. I have not just written in a paragraph. I have made 3 points here. So first, what does the forefinger indicates? It indicates the direction of magnetic field. Got it? And you should not write forefinger indicates magnetic field. You should say forefinger indicates the direction of magnetic field. And what does the middle finger indicate? Middle finger indicates the current, direction of current that is produced. If you know the direction of magnetic field, if you know the direction of current that you are supplying, then you can find out in which direction the motor rotates. That's what your third point says. Then the thumb indicates the direction of motion of conductor. Got it? So this is how you will explain Fleming's left hand rule. Now we will see the working. You can see that first 3 points I have tried to explain the diagram here. So how was the diagram made? A motor consists of a rectangular coil ABCD. This is coil ABCD. What is it made up of? It's made up of insulated copper wire. Clear? And the next point, the coil is placed between the poles of magnet. The same thing how you did for generator. Where is the coil placed? In between the magnet. And where are the coils are connected? The coil is connected to brushes XY and to split ring, that is PQ, and in turn they are connected to a battery. That's what I have told here. A current in the coil ABCD. Now how does a current come? See, I have written the plus direction here, minus symbol here. So the current always flows from plus to minus, correct? So the current comes from the plus and passes through your split ring P and brush X. It goes like this and comes back through Q and Y and reaches the battery back here. So this is the direction of flow of current. That's what I've written here. The current in the coil enters from the battery through brush X and flows back through brush Y. X takes it and Y gets it back. Got it? And now you are trying to explain what actually happens. Now imagine the current is flowing in the battery through this one, X, and it goes in the direction A, B, C, D. Correct? Now how will you know in which direction the rotation is seen? So for that you need to apply Fleming's left hand rule. Now here you got to know what is the direction of current. Arrange 3 fingers in your left hand. Now which is the one which shows current? This is current. The current is upwards, right? And what is the direction of magnetic field? North to south. 4 finger points the direction of magnetic field. Middle finger points the direction of current. Then what is the direction of motion of conductor here? It is inside the board, that is downwards. The side AB is pushed downwards and CD is pushed upwards. That's what you can see here. Okay, when the current flows in the direction ABCD, according to Fleming's left hand rule, the coil experiences a force. AB is pushed downwards and CD is pushed upwards. Okay, that's what happens in the first rotation. And what happens in the next rotation here? When the next rotation happens, here if the split rings are not used, the coil should rotate like this and it comes back like that because the direction of current changes. But here you are using slip rings. Slip rings, what happens? Which was the split rings which was like this, it goes like this now. So what happens? The point here, check here, P was here, Q was here, right? When it comes like this, P comes this side, Q comes this side. So direction of PQ reverses. So P, which was in contact with X, now gets the contact of Y. So therefore the direction of current changes again. So because the direction of current is changing, the rotation remains uniform. So now what happens? See, in the next half rotation, split ring reverses the direction of current and now the side CD is pushed downwards. Now AB was pushed like this, right? Now CD is pushed downwards, AB is pushed upwards. Therefore you will see continuous rotation of motor. Clear? So there you will see continuous rotation of motor. It's because you are using split rings. Clear? And see this. The armature shows complete rotation. The device that reverses the direction of flow of current is called a commutator. Who's acting as commutator here? It's split rings. So split rings help in the reversing the direction of flow of current and therefore it keeps up the direction of rotation in the same direction. It keeps the armature rotate continuously. Now imagine you are using slip rings here. What are slip rings? The 2 rings what we saw in generator. In that case, if you use a slip ring in case of this, how will the rotation be seen? It will be seen something. See, this is the armature, right? Here you have one rotation like this, one rotation. You see the rotation like this. Okay, because you are using split rings here, the rotation will be continuously seen like this. Clear? So that's the difference between split rings and slip rings. If you use split rings, you are getting direct current. If you are using slip rings, then you are getting alternate current. This is the working of DC motor. And what is the last point that I wanted to add on is the uses. Uses of DC motor. Where will you use the DC motor? You will use in refrigerators, electric fans, and this MP3 players. Whatever device you take, everything uses a motor. So you write 2-3 devices that uses motor. Yes, as you did for generator, for motor also you can take a screenshot of the notes that I had written on the board and you can study from that. Again, don't try to copy as is, instead learn and try to write on your own.